So welcome to apcalculus. We will be discussing the topic applications of integrals here. So we start with average value of a function over an interval ab. This is 1 by b minus a integral a to b fx dx. Average rate of change of fx over an interval ab is fb minus fa by b minus a. Again, when you integrate the acceleration, integral at dt is v plus c, integral of acceleration is velocity, integral of velocity is the displacement plus c, and the total distance travelled will be integral of modulus of vt dt. So, to find the total distance travelled, we find the points where velocity is 0 and divide into intervals depending on the sign. So let's start with the question. A particle moves along the x-axis with velocity vt equal to t squared minus 4 meter per second. Find the total distance travelled from t equal to 0 to 3 seconds. So when we put vt equal to 0, we get t squared minus 4 equal to 0. So t equal to plus or minus 2. So distance travelled between 0 to 3, you can write it as integral 0 to 2. 0 to 2, t squared minus 4 will be negative, so it will be 4 minus t squared dt. And 2 to 3, t squared minus 4 is positive, so it will be t squared minus 4. And when you integrate, you get 4t minus t cubed by 3 within the limits 0 to 2 plus t cubed by 3 minus 4t within the limits 2 to 3. So your answer is 22 by 3. Now, if RT represents the rate at which water flows into a tank, integral a to b RT dt represents the total water added to the tank between time t equal to a to b. And final amount will be initial amount plus net change. So let's go to a question. Water flows into a tank at the rate of Ft equal to 10 root t liters per hour. At t equal to 0, the tank contains 50 liters. Find the water in the tank at t equal to 9. So your amount of water will be the initial amount, that is 50, plus 0 to 9. So 0 to 9, 10 root t dt. That will be 10 integral t raised to half is t raised to 3 by 2 by 3 by 2 within the limit 0 to 9. So you get 230 liters. Now we have the cross-section method to find the volume, which states that when a solid's cross-section perpendicular to an axis have a known shape, then we find the area AX or AY of the cross-section. And volume is given by integral a to b AX dx or integral c to d. This is c to d AY dy. Then we have the dishwasher method, which is used when a solid is formed by revolving a region around an axis. So in this case, volume is integral a to b r1 squared minus r2 squared dx or pi times integral c to d r1 squared minus r2 squared dy, where r1 is the outer radius, radii are the distances from the axis of rotation, r2 is the inner radius. If the area of cross-section perpendicular to the axis of rotation is a solid circle, we use the disk method. If the area of cross-section is a ring, we use the washer method. So basically when there is a gap like a donut, then we use the washer method. When the cross-section is perpendicular with respect to the x-axis, integrate with respect to x. And when it is perpendicular to the y-axis, integrate with respect to y. So there are some basic formulas which we use in cross-section here. I'll just quickly go through it. For a square, it is top minus bottom squared. For a semicircle, it is pi by 8 into top minus bottom squared. For an equilateral triangle, it is root 3 by 4 into top minus bottom squared. And again, when it is perpendicular with respect to the y-axis, the area will be right curve minus left curve the whole squared. For a semicircle, it will be pi by 8 right curve minus left curve the whole squared. Equilateral triangle will be root 3 by 4 right curve minus left curve the whole squared. The cross-section formula is given by area of a square is s squared. For a semicircle, it is half pi r squared. For an equilateral triangle, it is root 3 by 4 a squared. For an isosceles triangle, it is half s squared, where s is the base. For an isosceles right triangle, it is half s squared, where s is either the hypotenuse or the base. So let's go into a problem. Find the volume of the solid whose base is the region bounded by the curves y equal to x squared and y equal to x. Cross sections perpendicular to the x-axis are squares. So if you find the points of intersection of y equal to x squared and y equal to x solving simultaneously, if I put x equal to x squared, x is 0 and 1, and substituting for y, your points of intersection are 0, 0 and 1, 1. So this is y equal to x and this is y equal to x squared. So when you find the volume of the solid, it will be integral left limit to right limit x equal to 0 to 1, top curve minus the cross sections perpendicular to the x-axis are squares. What is the formula for area of a square? It is s squared. So it will be top limit, that is x, the bottom limit is x squared, x minus x squared, the whole square dx. When you come to the cross section, that's what we do. Cross section is a square. So we use the formula for area of a square. That will be integral 0 to 1 x squared minus 2x cubed plus x raised to 4 dx, and when you integrate you get 1 by 30. So we have learned basic formulas of definite integrals and basic cross-section formulas and how to calculate volume of a region when the cross-section is perpendicular to the x-axis. Thank you.